Hello, ladies and gentlemen, and welcome once again. This is Mr. Donahue. We're going to take a look at some pre-organic review problems, some problems that are going to test some skills that we need to have before we can learn this new content. So number one, what is the empirical formula of a compound that has a carbon to hydrogen ratio of 2 to 6? So it's saying it should be a C2H6 is our ratio, but it wants the empirical formula, so we got to simplify it. So we're going to get CH3 because we can divide each of those by 2. So the correct answer is B. Which pair consists of a molecular formula and its corresponding empirical formula? So we need the molecular formula and the empirical formula. And if we take a look, the correct answer is going to be C, because we can go P4O10. Hey, we can divide each of those by 2, and we'll end up with P2O5, and there's no common factor of 2 and 5, so there's our empirical formula. 3. An atom of argon in the ground state tends not to bind with an atom of a different element because the argon atom has what? And it is choice B, a total of 8 valence electrons. Remember, that is the stable octet. That is why the noble gases are so noble. They don't react with anything. They have 8 valence electrons. All right, 4. Given the balanced chemical equation, and this stupid little comma here should be an arrow, what's happened in this reaction? Well, we have Cl2, so we have Cl, here's a molecule of chlorine, and then we break it up. So we're breaking a bond. So what has to happen in order to break that bond? Energy needs to be absorbed. So we're looking at option A for problem number 4. It's like having two magnets that are stuck together. If you want to separate them, you got to put in energy. So energy is absorbed to break bonds. 5. When sodium and fluorine combine to produce the compound sodium fluoride, the ions form the same electron configuration as an atom of what? Well, if we take a look at sodium, its configuration is 2-8-1, and fluorine is, where is that fluorine? 2-7. And what's going to happen is, well, hey, sodium is going to give that 1 valence electron to the fluorine, so it's going to become 2-8, and fluorine is also going to become 2-8, which is the same electron configuration as neon. Right? If we take a look, hey, this sodium right here is losing 1 electron, so it becomes neon. This fluorine right here is gaining 1, so it's becoming the same configuration as neon. So, yeah, choice C. I didn't circle it, but there you go. 6. Which element has an atom with the greatest attraction for electrons in a chemical bond? This attraction for electrons in a chemical bond is called electronegativity. So it's really asking which of these has the greatest electronegativity. And if you remember patterns, you don't need to look at the reference table S. You can go, hey, I'm looking at nitrogen, I'm looking at phosphorus, I'm looking at bismuth, I'm looking at astatine. So the higher up it goes, the higher the electronegativity, which I'm going to abbreviate EN. So higher up in a group, the higher the electronegativity, which is going to tell us that nitrogen. Or if you want to be safe, you can always just look it up. You go to table S on your reference table, and you go, hey, look up these values. So nitrogen says it's 3.0, phosphorus is 2.2. I look up bismuth, it's 1.9, and astatine is 2.2. So which one has the greatest electronegativity? Choice A. 7. Which substance contains bonds that involved the transfer of electrons from one atom to another? So what is this? What kind of bond is this? A transfer of electrons. That's going to tell you that it's ionic. So you're looking for a metal with a nonmetal. So which one of these? Well, let's see. Nitrogen, hydrogen, only nonmetals. Chlorine, nonmetals. Carbon and oxygen, only nonmetals. Hey, potassium, that's a metal. Bromine, that's a nonmetal. Boom, there you go. That is the ionic bond. 8. The bond Ba and BaO, barium oxide, are best described as what? Well, again, barium is a metal and oxygen is a nonmetal. So what kind of bond do we get when we get that? Ionic. So it's definitely not B or D. And it's ionic because valence electrons are transferred, right? We have barium with 2 valence electrons. We got oxygen with 6. So barium is going to give its valence electrons to the oxygen so that they both end up with 8 valence electrons. 9. Which of the following Lewis electron dot diagrams represents calcium oxide? All right, so let's figure it out. Calcium, I look it up, has 2 valence electrons. Oxygen, again, has 6. And I'm going to color these ones in, all right? So how's it going to happen? Well, this is a metal, and oxygen's a nonmetal, so they're going to transfer electrons. Calcium is going to give up its 2 electrons to oxygen. Oxygen's going to gain those. Well, electrons are negatively charged, so now this oxygen has a -2 charge, and this calcium that lost the 2 electrons is a +2 charge. And let's see, can I erase? Boom, look at that. So I'm looking for something that looks like this, and sure enough, choice B, calcium +2, oxygen -2. 10. Based on bond type, which of the following compounds has the highest melting point? So if we're talking about bond type, we're looking for covalent versus ionic. And ionic compounds have higher melting points. And the reason for that is we have full-on positive and negative charges being attracted to each other in ionic compounds, whereas in covalent compounds we only have like slightly positive ends and slightly negative ends being attracted. So it's easy to break that, whereas ionic bonds we have these full-on positive and negative charges. So in order to melt them and be able to have those opposite charges flow past each other, we're going to have to get hotter. So which one of these is ionic? Well, let's see. Carbon, hydrogen, oxygen. Hydrogen, only nonmetals. Carbon, chlorine, only nonmetals. Carbon, hydrogen, only nonmetals. Calcium, that's a metal. Chlorine, that's a nonmetal. We have an ionic bond right there. Choice B. Right, 11. Which compound has both ionic and covalent bonding? Interesting. We need ionic and covalent. So I need a metal and multiple nonmetals. Usually with a question like this, the covalent bonding is in some sort of polyatomic ion. So let's take a look. Calcium carbonate. I have calcium, which is going to be my metal, and carbonate, which is a CO3. So we take a look. Carbon is a nonmetal. Oxygen is a nonmetal. So these are bonded covalently to each other. So the carbon and the oxygens are covalently bonded, but together they are ionically bonded to the calcium. So I'm looking at calcium carbonate. Here it's only nonmetals, only nonmetals, only nonmetals. So none of these have any ionic bonding, whereas option A does. 12. Which substance are covalent compounds? So again, if we're looking for covalent compounds, we're looking for ones that are only nonmetals. So carbon, hydrogen, oxygen, potassium, that's a metal, so it can't be A. Potassium and iodine, metal and a nonmetal, that's ionic compound. Sodium and chlorine, metal and a nonmetal, that's ionic compound. Carbon, hydrogen, oxygen, only nonmetals. Hydrogen, chlorine, only nonmetals. Going to be choice D. 13. As a bond between hydrogen atom and a sulfur atom is formed, electrons are what? Well, let's take a look. We got hydrogen, which is, again, a nonmetal. We have sulfur, which is, hey, also a nonmetal. So how do nonmetals bond? They covalently bond. And how do they do that? What is a covalent bond? They share electrons. So we're looking for covalent and sharing electrons. So shared to form a covalent bond. Hey, choice A. Perfect. An oxygen molecule contains a double bond. So if I'm drawing the oxygen molecule, there is a double bond there. Because the two atoms of oxygen share a total of, well, it's really just asking you how many electrons are right there. And each line is a pair. So we have 2 pairs, which is a total of 4 electrons. Well, why does it do that? All right, good question. Don't gotta yell. All right, so if I take a look, oxygen has a total of 6 valence electrons. So 1, 2, 3, 4, 5, 6. And then let me draw another oxygen. So magic number to get to is 8, and they both have 6. So they go, hey, wait a minute, why don't I kick in 2 that I will share with you, and oxygen, you do the same thing, and you kick in 2. So what happens is now this oxygen right here kept 4 electrons for itself, and it's sharing 2 electrons. And this oxygen did the same thing. It kept 4 electrons to itself, and it kicked in 2 to share. So now, if you take a look at it, it's kind of like a Venn diagram. This oxygen has 8, right? Because it's got 4 kept and it's sharing 4. And this oxygen also has 8 because it kept 4 and it's sharing 4. That's how you get 8 valence electrons by sharing. All right, 15. What is the total number of pairs of electrons shared in a molecule of N2? So again, same thing. Nitrogen has a total of 5 valence electrons. So how do we get to 8? How many more does it need? It needs 3 more. So it goes, hey, why don't I kick in 3? And you do the same thing. You kick in 3, and we'll share those 6 electrons. You get to keep 2 for yourself, and we end up with hey, I kept 2, but I put in 3. I don't know how I should do this. All right, I'm going to do it this way. I shared 3, you shared 3, and you also kept 2 for yourself. So we have a total of 3 pairs, right? Here's 1 pair, here's 2 pair, and here's the 3rd pair, which is why nitrogen, the molecule, is written like that. 16. The degree of polarity of a chemical bond in a molecule of a compound can be predicted by determining the difference in electronegativity, right? So that's it. Polar bond, non-polar bond, you look at the electronegativity. 17. The chemical bond between which 2 atoms is most polar? So if we have a greater E&D, electronegativity difference, then we have a greater polarity. So to figure this out, you're going to have to use your reference table S. So table S is what you're going to want to look at. So let me look at my cheat sheet. Carbon has an electronegativity of 2.6. Nitrogen has an electronegativity of 3.0. So we get a difference of 0.4. Silicon, I look up. It's got an electronegativity of 1.9. I look up oxygen. It's 3.4. So it gets an electronegativity of difference of 1.5. Do the same thing for sulfur. I look it up. It's 2.6. And chlorine, I look up. It's 3.2. So the difference between there is 0.6. And hydrogen, it doesn't matter. It's 0. The difference is 0 because it's the same element. So which one is the most polar? The one with the greatest electronegativity difference. 18. Which of the following formulas represents a polar molecule? So we're not talking about bonds anymore. We're talking about a molecule. So we have to take a look at the shape of the molecule. If I have H2, it's going to come down to the lines of symmetry. If there's 1 or 0, then you have a polar molecule. If you have 2 or more, then you have a nonpolar molecule. So hydrogen, H2, we have 1, 2 lines of symmetry. That's nonpolar. H2O has a structure like this because oxygen has these 2 pairs of unshared valence electrons, and we only get 1 line of symmetry. So 1 line of symmetry tells me that it's polar. And hopefully you know water's polar, like just I'm doing it a million times. All right, CO2, its structure would look like this. And again, it's got 1 line of symmetry, 2 lines of symmetry, so that would make CO2 nonpolar. CCl4, running out of room, CL4 is going to look like this. And it's going to have the same problem as CO2 did. It has 2 lines of symmetry, so that would make it nonpolar. 19. Which formula represents a polar molecule? Same thing but different. All right, let's take a look. We got Br2. So again, Br2 is going to be Br. Br, that's its Lewis structure. It's got 2 lines of symmetry, so it's nonpolar. All right, CO2, we already did CO2. Looks like this. It's linear. It's got 2 lines of symmetry, which means it's nonpolar. NH3, let's see, we got N. It's going to look like this. It's got 2 valence electrons. It's not sharing. And 3 bonds with hydrogen. There's only 1 line of symmetry. So 1 line of symmetry means that it is polar. So it's looking like this is our answer. But let's check CH4. All right, CH4, carbon in the middle, 4 hydrogens surrounding it. Let's see how many lines of symmetry do we got there. 1, 2. We could even do diagonal in each direction. Makes it nonpolar. So 19, correct answer is C. 20. Which formula represents a nonpolar molecule? Okay, this time they're asking for the opposite. Let's see. HCl only has 1 line of symmetry, so that makes it polar. Not what we're looking for. CH4, we just did in the previous problem. It has many lines of symmetry. There's 1, there's 2. That makes it nonpolar, which is what we're looking for. But let's take a look at the rest of them. H2O has a structure that looks like this, and it's only got 1 line of symmetry, so it's polar. And then NH3, we did already again. It only has 1 line of symmetry, so it is polar. So it's not what we're looking for. 21. Which compound has hydrogen bonding between its molecules? So hydrogen bonding is an attractive force. So it's what holds molecules together. It's why, water has such a high boiling point. It's because it has strong attractive forces. It has hydrogen bonding. And when do you have hydrogen bonding? When you have hydrogen bonded to either nitrogen, oxygen, or fluorine. The way I remember that is just HNOF. I just remember HNOF. So I'm looking for hydrogen bonded to one of those three things. Do I have it in this? In A, CH4? Nope. Potassium hydride? Nope, don't have it there. Calcium hydride? Nope. Ooh, look at this. Nitrogen with a hydrogen. Hydrogen bonding right there. 22. The relatively high boiling point of water is due to water having, I already kind of jumped the gun on this one, hydrogen bonding, right? So we have hydrogen bonded to oxygen, and oxygen is very electronegative, so the electrons are pulled towards the oxygen, and that makes the oxygen very slightly negative, and the other side very slightly positive. So when we have another water molecule hanging out near it, we have a very strong interaction between those partial charges. Whereas if I had something like, I don't know, hydrogen sulfide, there's not as much of a difference between the sulfur and the hydrogen, so we don't get a very significant polar bond. In fact, yeah, so that's why. 23. Which of the following statements explains why low temperature and high pressure are required to liquefy chlorine gas? So if we want to make chlorine gas a liquid, we need to increase the pressure and we need to drop the temperature. And the reason for that is it has weak attractive forces. So chlorine has weak intermolecular attractive forces. If there's two chlorine molecules hanging out, there's no real attraction there because there's not any strong attractive forces. So they don't care about hanging out with each other, which is what needs to happen for the liquid phase to occur, right? They don't care. They'll spread out. They're fine with that. So it's going to be difficult to liquefy them because they have no attraction. 24. Which statement explains why Br2 is a liquid at STP and I2 is a solid at STP? So we got liquid versus solid. So here, with the solids, they have a stronger intermolecular attractive forces, whereas liquid has weaker intermolecular attractive forces. So I'm looking for an option that jives with that, and I think it's going to be B. Molecules of I2 have a stronger, right? So it's saying I2 is a solid, whereas bromine is a liquid. So yeah, I2 has stronger intermolecular forces than molecules of bromine. 25. A compound has a molar mass of 90 grams per mole. An empirical formula CH2. What is the molecular formula of the compound? So first step is, all right, if it's empirical formula CH2, I got to figure out what is the molecular mass going to be for that empirical formula. So I know each carbon is 12.0 grams per mole. Hydrogen, there's two of them, and they're each 1.0 grams per mole. And then oxygen is 16.0 grams per mole, and I end up getting 30.0 grams per mole for my empirical formula. Now it's telling me that the molecular formula has a mass of 90. So I go, all right, well, if I'm trying to get to 90 grams per mole, and I'm counting by 30s, how many times do I got to count by 30s? I get 3. So I got to take this CH2O, and I got to times everything by 3. So I end up with C3H6O3, which is going to be choice C. All right, last but not least, a compound has the empirical formula CH2 and a gram formula mass of 60 grams per mole. What is the molecular formula of the compound? Again, so I go CH2O. I know each carbon is 12.0. Plus, I got 2 hydrogens at 1.0, and I have this one oxygen, which is 16.0. So the mass of each CH2O is 30.0 grams per mole. It's telling me the whole molecule is 60 grams per mole. Now, if I'm counting by 30s, how many times do I got to do that to get to 60? I just got to do it twice. So I got to do 2 times this CH2O, and I end up with C2H4O2, which is choice A. All right, cool. I hope you found that helpful. I'll see you in class. Okay, bye.